I hope all of you are doing good. Let's start today's chapter, factors and multiples. Factors. If two counting or natural numbers are multiplied together, then each of these numbers is called a factor of the product so obtained. Thus, in the mathematical sentence, 5 into 8 is equals to 40. So, 5 and 8 are factors and 40 is the product, okay, which you already know. You have learned this in previous classes also. These are the factors, okay. We can also see that 40 divided by 5 is equals to 8 and 40 divided by 8 is equals to 5, and there is no remainder in each case. Hence, we can see that if a counting or natural number divides another number exactly without any remainder, the divisor is a factor of the dividend. Okay. For example, list all the factors of 40. So, here we have to list out all the factors of 40. So, 1 into 40 is 40, 2 into 20 is 40, 4 into 10 is 40, 5 into 8 is 40. Okay. Therefore, the factors of 40 are 1, 2, 4, 5, 8, 10, 20 and 40. And if factors of 11 are only 1 and 11, because 1 into 11 is 11. Okay. Therefore, the factor of 11 are 1 and 11. It is clear from the above examples that every number has at least 2 factors, 1 and the number itself. All the factors of a number are less than or equal to the number, not greater than it, right? Some facts. A prime number, a number greater than 1 which has no factors other than 1 and the number itself, okay. Example, all these numbers are prime numbers because all these numbers have only 2 factors, 1 and the number itself, okay. 2 is the only even prime number. All other prime numbers are odd, remember that, okay. Only 2 is the only even prime number. Next, a composite number. When whole numbers greater than 1 which are not prime are called composite number. For example, all these are composite numbers, okay. A composite number has more than 2 factors, right. 1 is a unique number since it is neither composite number nor prime. Its only factor is itself, that is 1. A multiple of a number is the product of that number and a natural number. Example, see, 8, 16, 24, 32, 40 and so on. 8 into 1 is equals to 8. 8 into 2 is equals to 16, 8 into 3 is equals to 24, 8 into 4 is equals to 32 and 8 into 5 is equals to 40, etc. A factor is a divisor which divides a number exactly leaving remainder 0. Example, write all factors of 40. So, here we have written all the factors of 40, or you can also divide like which we studied in previous class, like 40 divided by 1 is equals to 40, 40 divided by 2 is equals to 20. Okay, 40 cannot be completely divided by 3, so we will skip this number. Instead, we will divide 40 by 4, so we will get 10. 40 divided by 5 is 8. We will skip 6 and 7 also because these two numbers cannot divide 40 completely. 40 divided by 8 is equals to 5. Okay, 9 also cannot divide 40 and 10. 40 divided by 10 is equals to 4. Now, factors. These are the factors. First, we will go down like factors of 40. 1, 2, 4, 5, 8, 10. Now, we will go upward. 4, 5 already written, 8 already written, 10 already written, remaining 20 and 40. So, these are the factors of 40. Okay. Okay, except 1 and the number itself, rest of all the factors are called proper factors, right. A prime factor is a factor which is a prime number. Example, prime factorization of 60. 60 is equals to, so see, 60 you can write 2 into 30, this is the prime number. We can write 30 as 2 into 15, now this has become prime. Then 15, how can we write 15 as 3 into 15? And check all these 4 numbers are prime numbers, okay. Next, example 7 is a prime factor of 35. 5 is a prime factor of 35. 2. Co-prime numbers. Two different numbers that do not have a common factor other than 1 are called co-prime numbers. They are called a twin prime also. Example 12 and 17. These have no common factor other than 1. 18 and 25 are co-prime. Remember, it is not necessary that co-prime numbers will always be prime numbers. Example 12, 18, 25 are not prime numbers. Okay. Divisibility and divisor. If a number can be divided by another number with a 0 remainder, then the second number is the divisor of the first number. Example, consider the number 18. Okay. 18, its factors are 2, 3, 6 and 9, 18. All these are the divisors of 18. Okay. Now, prime factorization. Any composite number can be written as a product of prime numbers. An expression written as a product of prime factor is called the prime factorization of the number. Example, let's find out the prime factorization of 90. Number one method is factor tree method. Okay. Three 30s are 90. Okay. Then 3 10s are 30. 2 5s are 10. Okay. Now see 3, 3, 2, 5. These all are the prime factors. Okay. Or you can also make a factor tree. Means you can add, you can write any table. Okay. Like 2 into 45 is also 90. Okay. 9 into 10 is also 90. Right. So let's check out this method. 90 to 45. Then here 5 into 9. 3 into 3. Factors will remain same. Okay. Write the number to be factorized at the top. Right. Choose any pair of factor as branches. If either of these factors is composite, factorize again. Okay. Choose a pair of factors of each composite number. Continue the branches of prime factors. Number 4. Keep factoring till you have a row of prime factors. Therefore, 90 is equals to 2 into 3 into 3 into 5. Try for more factor trees for the number 90. At the end, the prime factors will be the same. Okay. For example, in this case also, we got the same prime factors, right? Okay, this was the first method. Now, let's check out method 2, that is continuous division. Okay. Start dividing by the smallest prime factor until you cannot divide anymore. Then continue dividing by the next higher prime factor. Repeat the process till you get 1. The prime factorization of 90 is, let's check out. We'll start with the smallest prime factor. Okay. Since it is an even number, so it can be divided by 2 completely. So 2, 45. Now it is an odd number. Now we'll start with not, now 2 cannot divide this. Now we'll try with the next prime number, which is a 3. 3, 15. 3 5s are 15, 5 1s are 5. So these are the prime factors of 90. This is the division method, or you can say continuous division, right? Next, highest common factor, that is HCF. If a number is a factor of 2 or more whole numbers, is called a common factor of these numbers. For example, 2 into 6 is equals to 12 and 2 into 5 is equals to 10. Here 2 is a common factor of 10 and 12. Okay, the highest common factor, that is HCF of 2 or more number, is the greatest of these common factors. Okay, example 1, find the HCF of 24 and 40. Method, we find the HCF of 24 and 40 by listing factors. Number 1, list all the factors of each number. Number 2, identify common factors. Identify the largest number in the list of common factors. So here are factors of 24. Okay, so we'll write here factors of 24. 1, 2, 3, 4, 6, 8, 12 and 24. and factors of 40, 1, 2, 4, 5, 8, 10, 20 and 40. Okay. Now find out common factor out of these factors. So, common factors. What are the common factors? 1, 2, 4 and 8. So, there are 4 common factors. Now, you have to find out the HCF, that is the highest common factor. And out of these common factor, which is the highest or which is the largest? It is 8. So, HCF is 8. Okay. And sometimes it is called GCD. HCF is also called a GCD, that is greatest common divisor. Okay. Method 2 is we will find HCF by prime factorization method. We will find HCF of 24 and 40. Let's see. 24. 2 12s are 24, 2 6s are 12, 2 3s are 6 and 3 1s are 3. Okay. And 40. 2 20s are 40, 2 10s are 20, 2 5s are 10 and 5 1s are 5. Okay. So, 24, 2 into 2 into 2 into 3 and 40, 2 into 2 into 2 into 5. Okay. Now, you have to find out the HCF. Okay. See, 2 common, 2 and then one more 2 is common. Now, multiply all these numbers. 2 into 2 into 2 is 8. So, HCF is 8, right. Example 2, find the HCF of 12, 18 and 42. In solution, divide the numbers by common factors only. Stop dividing when there are no more common factors except 1. Find the product of common factors. Okay, now we have to find out the HCF of 12, 18 and 42. So, here what will you do? First step, we will divide by the common factors, and common factor is 2. 2 6s are 12, 2 9s are 18 and then 2 21s are 42. Now, 3 2s are 6, 3 3s are 9, 3 7s are 21. Now, we do not have common factors of these number except 1. So, we will stop dividing. So, what will be the HCF? 2 into 3. So, 6 is the HCF of these numbers. Okay. Next, HCF of large numbers. This is method 4. Okay. This was method 3, now method 4. It is easier to find the HCF of large numbers by division method. Example, find the HCF of 144 and 252. Step 1, divide the greater number by the smaller number. Step 2, make the remainder new divisor and the original divisor the new dividend. Repeat the process until you get a 0 as remainder. Okay. So, the last divisor is a required HCF. Therefore, the HCF of 144 and 252 is equals to 36. Let's do it. Now we will use division method, right? And here division method we will use for the greater numbers. Okay. So, we have two numbers 144 and 252. Obviously, we will divide greater number by smaller number. Okay. 144 ones are 144. Okay. 8, 0 and 1. Now, step 2, this is the remainder. Step 2 is make the remainder the new divisor. Okay, it will become the divisor and the original divisor, which is 144, the new dividend. Okay, now let's divide. 108 ones are 108. Okay, so what will get? 6 and 3. Okay, remainder, you have to make remainder divisor and the original divisor you have to make the dividend. Okay, and then 36 3s are 138. Now the remainder is 0. So, which is the last divisor? 36. Hence, 36 is the HCF, right? Let's do exercise 3.1. List the factors of 54. Okay, let's find out. You will divide 54 by 1, you get 54. 54, you will divide by 2, you will get 27. And 3, what you will get? 18. Okay. Okay. 54 cannot be divided by 4, cannot be divided 5, since it doesn't have any 0 or 5 at one's place. Okay. Now we'll skip these two numbers and we'll divide by 6 is equals to 9. Then we'll skip a 7 and 8 as well, because these two numbers also cannot divide 54 completely. Now we will divide it with 9. So we'll get 6. Now factors of 54. First we will come down. Okay. 1, 2, 3, 6, 9, comma, then you will go up 6 and 9 we have written already, then 18, then 27, and then 54. So these are the factors of 54. Next, multiples. A multiple of a whole number is the product of the number and any counting number. Here are some multiples of 3 and 12. Multiples of 3. 1 into 3 is 3. 2 into 3 is 6. 3 into 3 is 9. 4 into 3 is 12. 5 into 3 is 15. Similarly, these are the multiples of 12. 0 is a multiple of every number. The smallest multiple of any number other than 0 is a number itself. And the number of multiples of a given number is infinite. Okay. Least common multiple, that is LCM. If a number is a multiple of 2 or more numbers, it is called a common multiple of the numbers. Example, 2 into 9 is equals to 18. Here 18 is common multiple of 2 and 9. The smallest number other than 0 that is a multiple of 2 or more counting number is the least common multiple or LCM of the numbers. Different ways to find the LCM. Method 1, by listing the multiples. Example 1, you have to find out the LCM of 6, 8 and 12. The multiples of 6 are these 6, 12, 18, 24, 30, 36, 42, 40 and so on, because multiples are endless, infinite in number. Okay. The multiples of 8 are 8, 16, 24, 32, 40, 48, and the multiples of 12 are 12, 24, 36, 48 and so on. So the common multiples are, what are the common multiples? 24, okay, 48 and 72. So out of these common multiples, which one is the least? 24 is the least. So the least common multiples of 6, 8 and 12 is 24. Okay. What you have to do is, step 1, list some multiples of each number. Step 2, identify common multiples. And number 3, pick up the least common multiple from the list of common multiples. Okay. This is method 1. Now method number 2, LCM by prime factorization. Okay. 18. Let's do it. 2 9s are 18. Okay. 3 3s are 9. Okay. Now we have 24 also. 2 12s are 24. 2 6s are 12. 2 3s are 6. Okay. Up 18 is equals to 2 into 3 into this 3 also, and 24 is equals to 2 into 2 into 2 into 3. Okay. Now you have to find out the LCM. What will be the LCM? 2, because it's common. Next common number is this 3. Now we will write the remaining factors. 2 into 2 into 3. So 2 into 3 6, 6 into 2 is 12, 12 into 2 is 24, and 24 into 3 is what? 72. Okay, so 72 is the LCM of 18 and 24. Method 3, LCM by division method. Okay, find the LCM of 16, 28 and 40. Step 1, divide the numbers by a prime factor common to at least to the given numbers. Bring down the number as such if it is not completely divisible by the prime factor. Step 2, stop dividing when there is no further common factor except 1. Step 3, find the products of the number in the left column and the last remainder. Okay, let's check out 16, 28, 40. First we'll start with a common factor, which was 2. 2 8s are 16, 2 14s are 28, and 2 20s are 40. Then again 2 2s are 4, 2 7s are 14, and 2 10s are 20. Now 2 2s are 4. Okay, we will write 7 as it is. Okay, then 2 5s are 10. Okay, now LCM. 2 into 2 into 2 and 2 into 5 into 7. Okay, so this will become 560. So 560 is the LCM. Okay, now let's do exercise 3.2. Find the LCM of 9 and 12 by listing multiples. Okay, in this question we have to find out the LCM, but we have to find out LCM by listing multiples. So we will write multiples of 9. Multiples of 9, 9, 18, 27, 36, 45, 54, 63, 72, and so on. Okay, and multiples of 12. 12, 24, 36, 48, 60, 72, 84, and so on. Okay, now common multiples. Common multiples are 36 and 72, and out of these, which one is the least? 36. So the LCM of 9 and 12 is 36, right? Divisibility rules. One natural number is divisible by another natural number if on dividing we get a remainder equal to 0. There are some rules or patterns that make it easier to tell whether a given number is divisible by another given number or not. We have been introduced to divisibility rules in class 4. Let's revise them here. Divisibility by 2 rule: if its once a digit is even or 0. Examples. Okay. 3, if the sum of its digit is divisible by 3. Okay, for example, these number, let's check. For example, 36, we will add these digits. 3 plus 6 is 9. 9 is divisible by 3, that means 36 is also divisible by 3. 4, if the number formed by its last 2 digits is divisible by 4 or last 2 digits are zeros. For example, 200, last 2 digits are 0, then it is divisible by 4, and 344, last 2 digits are 44, 44 is divisible by 4, then this number will also be divisible by 4. So we have to just check out the last 2 digits in case we are checking the divisibility of 4. 5, if its once digit is either 0 or 5. And 6, if it is divisible by 2 and 3. Okay, let's check. We'll take this example, 18. Let's check whether it is divisible by 2, of course, because it is even number. And what about 3? Let's check. 1 plus 8 is equals to 9. 9 is divisible by 3. That means 18 is also divisible by 3. So this number is divisible by both 2 and 3. That means it is also divisible by 6. Okay. 8. If a number formed by last 3 digit is 8 or last 3 digits are 0. For example, in this case, there are 3 digits. Last 3 digits are 3 zeros. So it is divisible by 8. Or we can check last 3 digits like 512 divided by 8. 8 6 are 48. 3 2. 8 4s are 32. Okay. This number is completely divisible by, means last 3 digits are completely divisible by 8. That means this whole number is divisible by 8. 9, if the sum of its digit is divisible by 9. And 10, if its once digit is 0. 11, if the difference between the sums of the digits in the odd places and in the even places is either 0 or divisible by 11. Okay, see, 121, we have this number 121. This is odd place, even place, odd place. Okay, like 1 2 3. So What does it say? Difference between the sums of the digit in odd place. Okay, let's do the sum of odd places. 1 plus 1, 0. Okay, and odd places, but there is only one odd place, so we will do the subtraction. Difference of the sum of odd places is 2, and at even place it is 2. So 2 minus 2 is equals to 0. Okay, so if it is either 0 or divisible by 11, so the answer is 0, that means it is divisible by 11. 12. If it is divisible by 3 and 4, okay, and 15 if it is divisible by 3 and 5, okay. Divisibility by some other numbers. We shall study a few other cases of divisibility involving prime and composite numbers. Divisibility by 7. A number of 2 digits is divisible by 7 if the sum of 3 times the digit at tens place and the digit in the ones place is divisible by 7. Example 63. Okay, let's do it. So we have this example 63. Okay, 63. Okay, what does the rule say? Sum of 3 times the digit at tens place. Which digit is at tens place? 6. Its 3 times is 6 into 3 plus sum 3 is equals to 21. 21 is divisible by 7, hence 63 is divisible by 7. Number 3, a number of 3, or here we were talking about 2 digits, okay, a number of 2 digits. A number of 3 or more digits is divisible by 7 if the sum formed by the last 2 digit, that is number formed by tens and units digit and twice the number formed by the remaining digit is divisible. Example, we have this number 1, 2, 2, 5. Okay, so what does the rule say? If the sum formed by the last 2 digits are these number formed by tens and unit digits and twice the number formed by the remaining digits 12, and we have to do the twice of this digit plus these digit. Okay, so 24 plus 25 is equals to 49, and 49 is divisible by 7. Therefore, 1225 is also divisible by 7, right? Now, divisibility by 10. This is very simple, very easy. A number is divisible by 10 if there is 0 in ones place, but 0 should be at ones place, okay? 0 is at ones place, 0 is at ones place, so both these numbers are divisible by 10. Divisibility by 18. We know that 18 is equals to 9 into 2. When 9 and 2 are co-primes, hence a number is divisible by 18 if it is divisible by both 2 and 9. Thus we say that a number is divisible by 18 if its unit digit is even and the sum of its digit is divisible by 9. Example 72. 72 is divisible by 18 since digit at unit place is even, and even that means it is divisible by 2, and sum of digit, that is 7 plus 2, is equals to 9. Sum of the digit is divisible by 9. That means this number is divisible by both 2 and 9, and this number is divisible by 18. Okay, consider a number 67896. Okay, 67896. This is even number, so it is divisible by 2. Now let's do the sum of the digit. 6 plus 7 plus 8 plus 9 plus 6. Okay, or after adding all these numbers we get 36, and 36 is divisible by 9. That means this number is divisible by 18, right? Divisibility by 25. A number is divisible by 25 if the number formed by its last 2 digits is divisible by 25 or if the last 2 digits are zeros. Example, 13,575 is divisible by 25 since the number formed 75, last 2 digit, is divisible by 25. Like next is 8,500, it is divisible by 25 since the last 2 digits are 0. Okay, next divisibility by 125. A number is divisible by 125 if the number formed by its last 3 digits is divisible by 125, or if the last 3 digits are zeros. Example is this. See the last 3 digit, 375. It is divisible by 125. Okay, so the whole number will be divisible by 125. And 1000 has 3 zeros, so it is divisible by 125, right? Let's do exercise 3.3. Look at the table given below and mention if they are divisible by the numbers given on the left column. One has been done for you. So you have to check out whether 88 is divisible by 6 or not. 144 is divisible by 6 or not. Okay. Similarly, you have to check all the divisibility, the numbers given here. Okay. So you will do it by yourself, and remaining questions also you will do yourself.